Rational equations. The process of solving rational equations is very similar to a process for solving equations that have fractions in them. We want to start by finding the LCD of the whole equation and multiplying that by both sides in order to clear the denominators. In this case, my only two denominators are x and x plus 2. Because these have no common factors, my LCD in this case is the product of those two denominators, x times x plus 2. So the first step here is to multiply both sides of the equation by x times x plus 2. And I can see that on the right-hand side I have two terms to multiply that by. So I do need to distribute it into this bracket here that makes up the right-hand side of my equation. Over here on the left, I really only have one term, so it makes it a little bit simpler to do the cancellation. I have an x in my LCD and an x in the denominator. Those will cancel, and all I will have remaining is 2 from the numerator and x plus 2 from the LCD. On the right-hand side, I have to be a little bit more careful about my cancellation. I can see that the x plus 2 factor will cancel out for my first product, leaving me 3 from the numerator and just x from the LCD. However, this time I'm choosing not to cancel these out with pen. I can demonstrate what that would look like if I did cancel these out. Cross out the x plus 2, cross out the x plus 2. The problem is that x plus 2 in my LCD only cancels for this one product. It does not cancel from the next product I'm going to do as I distribute it in. So it's best not to write this in pen, but instead just to visualize the cancellation that would occur. In my next term I have plus 1. Since nothing cancels from my LCD, I still have both factors, x and x plus 2 in this term. Generally, if we do this step of clearing denominators correctly, the rest should be a more familiar process. We do need to simplify both sides of this equation, so I'm going to distribute into my two sets of parentheses here and see what kind of equation I end up with. This is 2x plus 4 on the left-hand side. This is 3x plus 1x squared, or just x squared, plus 2 times 1x, which is 2x. Now I can combine like terms. On the right-hand side, I still have a plus 3x and a plus 2x, which can combine. Generally, it's a good idea to combine all of the like terms before we start moving anything back and forth across the equal sign. So this is x squared plus 5x at this stage. Now, because I have an x squared in this equation, I can see that this is a polynomial equation, and I can solve this by factoring. And it's because I want to solve this by factoring that I now am going to choose to get all of the terms on one side of the equation rather than getting the variable on one side and the number on the other side, which is more like what I would do for a linear equation. So what I will choose to do is move all of my terms to the right. If I move these terms to the right, then my x squared term will stay positive. If I were moving terms to the left, then I would end up with a negative x squared term, which is much harder to factor. I will move both of these in the same step now, so that on the left-hand side, 2x minus 2x, 4 minus 4, those are both gone, and I have 0. And on the right-hand side, I now have x squared plus 3x minus 4. This is a simple factoring problem, so we can use trial and error. Both factors must start with x for the first term to be x squared, and the factorization of 4 that seems to work here is 4 times 1. So I'm going to have plus 4 and minus 1 in my factors, which means that my two solutions after setting these equal to 0 would be x equals negative 4 and x equals positive 1. I'm not quite done at this stage. I do still have to come back and check my answers. And the way I check them is really just to make sure that they are in the domain. So if we go back to the original equation and look at the factors that are in the denominators, I can tell what my domain should be. This x in the denominator on the left-hand side tells me that x cannot equal 0, because that would give me a division by 0 error. And this x plus 2 in the denominator on the right-hand side tells me that x cannot equal negative 2, because x equals negative 2 would give me a division by 0 error in that rational term. Because neither of these are equal to those numbers that I had to take out of the domain, these are both in the domain, which means we can keep both of them in our solution set. So this is just a quick little check that we do at the very end. If we end up with a number that's not in the domain, then we have to throw it out. But in this case, it looks like we get to keep both. So we end up with a solution set containing the two values, negative 4 and positive 1.